Hello students, today we're going to take a closer look at parallel and perpendicular lines and continue and get some more properties from them. Please take notes as you go and complete the survey that follows this video. So let's look at a little introduction here. Jude and Jasmine leave school together to walk home. Jasmine cuts down a path from Schoolhouse Road to get to Oak Street. Jude cuts down another path to get to Court Road. Below is a diagram. What conjecture can we make about Oak Street and Court Road and why? Well, what we need to do is look at other angle relationships before we can conclude something about Oak Street and Court Road. So the first thing I want to ask you is, what's the relationship between Oak Street and Schoolhouse Road? Well, if we see that these two roads here are going left to right, and the path that Jasmine took here is a transversal between those two lines, so that if we observe a little bit closer, I'm telling you by these arches here that these two angles here, or the alternate interior angles, are the same. So what we can say is that those two streets are parallel, but the alternate interior angles converse. Remember, if their alternate interior angles are congruent, we can say that the two lines are congruent or parallel. So my next question is, how can I extend the path to help determine the relationships between Oak Street and Court Road? Well, if you extend the path and they intersect at one point that intersects both roads, then you might use the same side interior relationship. Meaning, if I were to continue this line this way, or continue this path this way, then it might, if I had the same angles here, I might be able to use the same side interior, seeing if it will add up to 180 degrees. Same thing with going this way. I can see if the angle formed, if it hit up here, as well as down here, forms 180 degrees, we might be able to use the same side interior relationship. Well, today we're going to be looking at the relationships of two lines to a third line, just as that, in order to conclude what is the relationship between Oak Street and Court Road, something like that. So we wanted to look at different types of properties or theorems that deal with parallel or perpendicular lines. So our first one here is a theorem. If two lines are parallel to the same line, then they are parallel to each other. Okay, so it's kind of like the transitive property, also like the law of syllogism. What I'm saying is that line A and line B are parallel to each other, and line B and line C are parallel to each other. If that's the case, we can automatically assume that these two lines, A and C, are parallel to each other. Our next theorem is, in a plane, if two lines are perpendicular to the same line, then they are parallel to each other. So in this case here, M is perpendicular to T. Line N is also perpendicular to T. Since these two lines are perpendicular to the exact same line, therefore, these two guys here are parallel to each other. And I want you to think of corresponding angles postulate. These two are corresponding positions, so since that's the case, we know that these are going to be parallel. This is just going a little bit further and discussing automatically about perpendicular. For corresponding angles postulate or the converse, we don't necessarily have to be perpendicular. The two lines just had to be parallel or congruent, or the angles have to be congruent. So in this case, we're specifying perpendicular. The last two theorems we show the lines were parallel. We can also show lines are perpendicular with a similar idea. So in this case, if I showed you that we have ourselves a line L that's perpendicular to 1, and I'm telling you that L and M are parallel to each other, now I can show you that M and N are going to be perpendicular. Again, it's the same idea. It's using the idea of the corresponding angles postulate. If we have parallel lines, then these two angles have to be congruent. Since this angle here is a right angle, that means this angle here has to be a right angle. Okay, so if we have a line perpendicular to one, and that same line is parallel to another, then that second line is perpendicular to the original transversal. If you have any questions, please make sure you write them down and bring them to class, or write them in the survey. Otherwise, take the survey that follows the video. I'll see you tomorrow.